Alright, everybody, let's continue with our Algebra 2 final exam review. And this is number 10 in our review packet. Um, this particular problem is really about complex numbers. And just as a reminder review, complex number is basically a combination of real number and imaginary number. Maybe in the future I'll make another video specifically lecture about to lecture on imaginary number as well as its relation to real numbers and usage of the complex number. Okay, so now let's start with this one. Part A. We have a 3x squared. Let me just write it out anyway. Repeat it again. 3x squared plus 4x plus 10 is equal to 0. Now this appears to be a quadratic equation. It is a quadratic equation. So I'm going to go ahead and use, and it doesn't seem like there's obvious easy factors out of this. So I will utilize quadratic formula to help me find the solution. So A is equal to 3, B is equal to 4, and C is equal to 10. So we have the solution based on quadratic formula. X is equal to negative B plus minus square root of B squared minus 4 times A times C divided by 2A. So applying all these numbers back in there, we end up with negative 4 plus minus square root of 4 squared, right, which is 16, minus 4, A is 3, C is 10, divided by 2A, 2 times 3. So x is equal to negative 4 plus minus square root, and you can use your calculator, 16 minus 4 times 3 times 10, you end up with negative 104 and divide by 6. Now it's pretty obvious that you cannot have a square root of a negative value, so you could think of it as negative 4 plus minus square root of negative 1 times square root of 104 divided by 6. So your final answer is negative 4 plus minus square root of square root of negative 1 is I, and square root of 104 divided by 6. So that's your solution for this quadratic equation. Now this is a complex solution because we had real number in combination with imaginary number I. Okay. Part B. B says write a quadratic equation if one of the solution is 3 plus 4i. Now the hint is that the other solution is the conjugate of 3 plus 4i. Now the conjugate, I'll start with first point. Conjugate of a two term is basically the other sign. So 3 plus 4i, the conjugate will be 3 minus 4i. So we could consider solution 1 is the first one, which is given to us, 3 plus 4i, and solution 2, S2, is equal to 3 minus 4i. Now I do that just simply because I can kind of use simpler notation for more complicated expression, right? Now here says these, this problem, part B, is kind of the opposite of the problem A. Part A, you're given a quadratic and you solve for a solution. Part B, you have a solution, right? but you had to come up with the quadratic equation in the first place. So the way to think about it, right? Equation. This is the equation that ends up to be 0. Now, if you have this quadratic equation that ended up to have solution 1 and solution 2, and it's use a quadratic equation, usually it's in a factor form. So usually we want to factor the quadratic equation and set it equals 0, so we can solve for each one of them, right? So typically we say x minus a solution 1, x minus a solution 2, because typically if we can end up having a quadratic equation, if we can turn a quadratic equation into a factor form like this, we typically can set x minus s1 equal to 0, and then we say x is equal to s1, right? X minus s2 equal to 0, x is equal to s2, right? That's how we typically do it, right? So in a sense, we're doing the same thing. we basically rewrite it in this expression. But since I already said the example, I have set s1 and s2 as the complex numbers, and s2 is the conjugate. Then I can just go ahead and replace that, x minus parenthesis 3 plus 4i, right? And the bigger parenthesis for that one, and then x minus s2, right? Solution 2 is parenthesis 3 minus 4i, big parenthesis, so it equals 0. So you see, this is basically equivalent, right? Becomes this, becomes this. And so then what I will do is go ahead and factor this out, and obviously this is a little complicated, but I'm gonna just keep 3 minus 4i and 3 plus 4i and 3 minus 4i as a singular unit as I factor this out, right? So let's simply just do for you, right? So x times x, we get x squared. So I'm gonna give myself a little room here. X times x, x squared. Okay, now x times negative 3 minus 4i is negative, right? 3 minus 4i times x. Do you see that? This times this is x squared. This times this is 3 minus 4ix. Okay, now the next one is this x, this one. Negative 3 plus 4i times x. Then we end up with negative parenthesis 3 plus 4i x. And then you got negative 3 plus 4i times negative 3 minus 4i will be positive, but we will have two parentheses, right? 3 plus 4i, 3 minus 4i, and then this one set it equal to 0. I'm running out of room. Okay, so now we're gonna just keep going with this, right? You may not know where this is going to. That's okay. You take the next logical step, right? So x squared, nothing changed, so we don't mess with it. X squared minus negative parenthesis 3 minus 4ix. So we multiply the x into it, right? So x times minus, now put a parenthesis, 3x, right? And then this is minus 4ix. Keep your parentheses, don't drop them, because you gotta, I'm breaking down to the detailed steps so that you don't make any mistakes along the way, dropping parentheses or forget to switch the sign and this and that. So be very, very careful, okay? Minus, now put a parenthesis again because I'm taking the x and multiplying in, right? So this one was multiplying in this way. I'm going to multiply this into here. So I got 3x plus 4ix. Put a parenthesis around it. plus. Now here's very important. Let's take a look at this. This is a 3 plus 4i times 3 minus 4i. Now this is a plus b times a minus b out here, right? So let's think of it this way, right? Let's put it right here. A plus b times a minus b. We end up with a squared minus b squared, right? And in this case, a is 3 and b is 4i, right? Do you see that? You see that? So I end up with an a squared, right? So a squared is 3 squared, all right? Minus b squared minus, and b is 4i squared, and set equals 0. Now very detailed, very slow in this process because I want to show you every single little step, so you don't take shortcut. If you're not really quick in capturing all the details, and because some people can jump steps, but they're holding on to the complexity of all these details as a skip steps, which is fine if you can do that. If you're not less confident about that, then don't take shortcut. Okay, just keep it going like this. So now let's keep going. X squared. Now this is just taking off the parentheses, but here we have a negative outside parentheses. So you see the one inside is going to change the sign. So minus 3x, then it becomes plus 4ix. And then over here is minus 3x, and then this is minus 4ix. Now this is very helpful because I already know that some terms are going to drop out. And then plus 3 squared, which is 9, minus 4 squared, which is 16, and then I squared, right? I squared. I'm going to use a red pen here. I squared is equal to 0. Now this is a very important point to make here. I squared, right? The way we define I, we define I as square root of -1. So what that means is I squared is square root of -1 parenthesis square, right? Square root of -1 parenthesis square. And so it just becomes what? Becomes -1. So I squared is -1. So I'm going to put I squared -1 and replace it with I squared right there. Okay? So this is an important point because this is the foundational steps for understanding imaginary number, right? This is a review part. Okay? So now x squared minus 3x plus 4ix minus 3x minus 4ix plus 9 minus 16. I squared becomes -1, but -1 times -16 becomes positive 16 equal to 0. Do you see how it works? This thing right here becomes -1, right? -1. So -1 times -16 becomes positive 16. Okay, a few things I also noticed, right? This term 4ix, positive 4ix, negative 4ix, canceled out. Okay, so now my next step is x squared -3x, -3x becomes -6x, right? Plus 9 plus 16 gives you plus 25, and then equal to 0. And guess what? this is a quadratic equation that would have given you the solution of 3 plus 4i. Oh, and also 3 minus 4i, for that matter. Okay? So there you go. That's part B. And then part C says factor 25x squared plus 1. Now, we know how to factor difference of square. We don't know how to factor the sum of square. Well, at least we don't have a formula, straightforward formula to factor sum of squares, right? We have a squared minus b squared, and we know that this just be a plus b times a minus b. Now that's minus right there in between, right? But this is a plus and it's 1. Well, it turns out that this is actually a easy fix. What we could do is we can rewrite this as 25x squared minus negative 1. Minus negative 1. Okay, that still doesn't quite look like this. No fear. Let's keep rewriting this. 25x squared can be written as 5x, the whole thing squared. And minus b squared. Okay, so I need to figure out what b is. But I know if I can write I can figure out the value for b, I know that I can, set a as 5x and whatever that b is, and I can follow this form. So now here is where we want to take advantage of our knowledge, right? If we say, well, this had to be the same, right? So b squared is equal to negative 1. So where have we known of any situation that when something gets squared is negative 1? We know that I gets squared is negative 1, right? Remember right here? Just right here. Right here, I squared is negative 1. So our b, so we can conclude that b is I. So coming back to this equation here, right, or expression here, 5x squared, or 5x parentheses squared, minus I squared. There you go, I have a difference of square. I can rewrite this as 5x plus I times 5x minus I. And there you go. That is my factor. So here you go. You have one problem that is dealing with imaginary number and complex number, but in the context of solving a quadratic equation or having a complex number as a solution, and then you had to go backward to find that quadratic equation. Alright, I'll see you in the next video on the next problem.